Welcome. As I'm pretty sure we're on. I'm pretty sure everything's going, so we're going to get started. My name is Jeremiah Johnson. I'm with Kratos Security and Defense Unmanned Aerial Systems, stationed here in Oklahoma City. And joining us today, we've got Mr. John Parks, the co-founder and chief strategy officer for Skydweller Aero Inc. We've also got Rick Gaeta. Did I pronounce that close?
Yep.
Excellent. Rick is the director of UAS R&D and the vice president of engineering Midwest for the Martin Defense Group. And we've also got Mr. Clifford Stone. Cliff Stone is the vice president of life cycle sustainment with General Atomics Aeronautical. So what we're going to be discussing today is cracking the defense contractor code, and just kind of let it kick off as we get moving. So we'll kind of start with a question that I'll direct towards Cliff. We'll let Cliff start. I think Cliff's on. There's Cliff. There we go. Cliff, how do you see UAS evolving and contributing to the defense strategy going forward?
Unmute, Cliff.
Yeah, Cliff, I think you're muted, sir. Are you there, Cliff? Or did we lose you?
Yeah, we're not hearing.
Cliff, Cliff, I still got you on mute. We'll see if we can get that figured out. But while we're try to hold your space bar down, Cliff, see if that'll give you the volume.
Or check your device and see if you can switch to your microphone.
All right. While we're working through that, let's we can.
Okay, I'm back.
Oh, there
I'm
we
back.
go.
I apologize. Things were working perfectly for the past 20 minutes, and then my computer died just before we started. But I'm back in business. So good. Thank you, Jeremiah. When you ask the next question, I'll change my name on the screen since I had to switch computers here. But in any case, so let me just brief introduction. So Cliff Stone, I do lead the sustainment team at Aero down in Southern California. And if you don't know who General Atomics is or what we do, please come to our virtual booth, and we'd be happy to talk to you all. To answer the question about future defense strategy, I think it might be important to talk about how things have worked over the past 20 years. And also, every time I'm in one of these things, I think we have to kind of set the context for we hear a lot about large UAS. Our products are large, 6,000 to 12,000 pounds, 80-foot wingspan, so very large drones that do both surveillance and strike very effectively over the past 20 years in the war on terror. And if you're into defense and in that industry, you know the defense strategy is changing away from counterterrorism to more near-peer type of fights. And what the DoD and what the Air Force specifically is thinking is going to be a game changer that we're very much involved in, and we've talked about some of this actually in this forum, are things like swarming, artificial intelligence, safe autonomy. And so in any case, we are working on all of those technologies, and we see not just an airplane or two flown by a crew and supported by a dozen or so maintainers, but we see motherships launching air vehicles, in sort of mass quantities. And so in any case, we are preparing ourselves and working both with industry as well as academia to be able to take advantage of those commercial kind of technologies as our customers demand, as their mission sets change, over the coming years and decades.
What we'll do with the panelists, guys, is where we'll ask a few questions to everybody on the group, and then we'll go back with questions. That way we don't get bogged down and everybody gets a chance to kind of introduce and go through their stuff, just so everyone on the panelists is aware kind of how we're going to run this. So we'll go and jump into another question with that, with Mr. Parks. So on your side, how do you feel the U.S. Department of Defense, not just leveraging new technologies, but also new business models, as it shifts its strategy and continues to increase top-line budget pressure? How do you guys at Skydweller manage that?
Yeah, so we see right now is a really interesting time, both in the DoD and in the UAS technology space, for the insertion of a lot of great new technologies, much like other panelists have mentioned, with small swarming UAS, new AI technologies. But we also see the DoD making a very strategic shift to looking at how they operate aircraft and looking at how do they use them in a more integrated or layered environment with space and seaborne assets and a variety of systems between land and space, and looking at how they lease these aircraft or use them as an integrated service versus purchase aircraft in a traditional sense. And so, within the DoD, historically, they would start a development program and say, we want X, Y, or Z, and some manufacturer would go out and build an aircraft. And I think in the future, you're starting to see more and more companies looking to iterate their aircraft and products more often and deliver that through a service capability.
Okay. Excellent. So, Mr. Gaeta, Rick, I got a question for you as well, so we can get going. I just had it. I lost it. There it is. How does Martin Defense work? I mean, basically with building bridges with academia to move the concepts for R&D.
Yeah. So at Martin, we're a primarily, or started out as a maritime ship architecture type company, and we're bringing UAS technology to the company. And so just let me echo what the others have said about the defense strategy moving to a more near-peer Pacific-based operations, where tyranny of distance becomes a very significant thing. Working with the universities and trying to develop technologies from new ideas and novel concepts, and to try to transition that to the warfighter is obviously the big, hard valley of death problem that we all face. And so there's roles to be played in all those cases, and the higher risk research can be done by universities in a more effective way in some sense, but they need to have, and I'm not going to use the often used term inside, outside the box, but there needs to be some sort of guidance as to how the academia takes those low technology readiness level concepts and can be pushed forward in transition. And so that's the challenge that we all have. And so what Martin is doing around the country, because we have offices all over, is to work closely with and have working agreements with universities that have technologies that feed the kinds of systems that we're working on. And so by having those close relationships, for instance, I'm in Stillwater, Oklahoma, with Oklahoma State. We also have an office we just opened up in Wichita with Wichita State University and their National Institute for Aviation Research, or NIAR group, that we can leverage and be able to kind of have contact with the end user, which is very important, and be able to drive some of those things all the way down. So trying to transition those feasible concepts to something that's more viable. So a very strong bridge or conduit to university research, we feel, is a force multiplier, if you will, for trying to transition technologies. Can't hear you, Jeremiah. I think you're on mute.
Yeah, you're on mute there, Jeremiah.
I was on mute. All right. So what we're going to do is I'm going to throw out a theme now and let the three of you kind of kick it around. And then we'll kind of go through that. We'll see if we can get to another theme as well, and leave probably 10, 15 minutes towards the end for question and answers. That way we can go through that. But kind of a theme for all three of you. I mean, your respective companies in that, how do you best leverage, commercial technologies to enable future missions and kind of drive where we're going long term using what's already available commercially?
I'll just make, I'd say right now, there's a lot of technologies that are mature in and of themselves. I think the key to making these things work for what we're interested in is it all comes down to systems integration and systems engineering. I think there's needs to be a high priority on that part of it, because we have all these technologies at different maturity levels, but a lot of it has to do with how you put them together. And usually the things that make it fail in terms of transitioning happens in the system integration area of it. So I find that the systems engineers are kind of ruling the roost here, because there's all of this collaborative work with all these different technologies.
Yeah, I can add on to that if you want, Jeremiah. This is Cliff. So yes, similarly, historically, General Atomics has been a very vertical company. And what we're finding, though, is that with some of the newer technologies available and really being required for the mission set that I mentioned, for example, command and control of swarms of drones, okay, as one example. What we're finding is that we don't need to be as vertical, and so that we do get to take advantage of technologies, some of which we've even actually just talked about today. Just one little example is obviously when our products fly 20, 30,000 feet and do a lot of surveillance and pointing and tracking of targets is obviously important. We did that, but we found a small company actually also here in the Los Angeles area, I think, called IJK Controls, that specialized and had state-of-the-art technology and pointing and tracking. And so we ended up actually purchasing that company. So that's just one example of a technology that was out there, kind of commercially available, wasn't made at home, that we got to take advantage of. And we see more and more of that. As Rick mentions, these are systems of systems anymore. They're not just an airplane being flown by a couple of crew, and maintained by some maintainers. So, so looking forward to more of that, actually. It's great to be here and see, I've heard some of the pitch presentations, and we're looking forward to taking advantage of other commercial, technologies that are being invented by others.
Yeah, and this is John Parks from Skydweller. To echo, the previous comments that, system integration is at the core of this. I think there is a business model change where right now companies do want to adopt commercial versus being more vertical because they want to be faster. Right now that the market is changing, there's all sorts of new problems that the U.S. Department of Defense is facing, and they're shifting their policy. And so as these platform providers such as us, Martin, or General Atomics, want to be more agile and adapt to all these emerging threats and challenges, we're going to look for different subsystem providers that have some great commercial off-the-shelf solutions and integrate them in. So at Skydweller, we're very focused on having an open mission system, making changes to the aircraft or the mission systems or the sensors, the radios, very quick, cheap, low cost, etc. because we want to be agile and responsive, and that way we can bring in these new commercial technologies quickly and have a differentiated solution.
Okay, which is good. I'm going to throw another question out there from being in some of the sessions earlier with the breakout sessions. I think this will be good for everyone involved, and kind of for our 30 plus attendees, kind of a good question to roll into it as well. What sorts of technology do you guys see will be required as the UAS industry grows through the future? I mean, what sorts of technology are you guys excited about that see where our future is leading us?
I think it was mentioned already by Cliff before, AI and I guess high autonomy and collaborative work with the swarms is going to be very, very important. I would add to that, because again of the shifting battle space, things like longer endurance and range and payload, which is always desired, but autonomous resupply, autonomous refueling, things that again we have to overcome over long distances that some of these systems have to operate in. So I see a lot of interesting new technologies on how to launch and recover aircraft in high sea states or in different environments like that, and on top of the AI.
Okay.
Just command and control of these systems of systems, collision avoidance, autonomous missions. And so how do you control the live, swarming, type of UAS environment is one. One of the things I'll be a little bit specific on, for example, AI is right now, it takes a human flying an airplane, another human surveilling with the video or the camera or the EOIR ball, and you have to train your eyes to detect a man moving or a truck pulling out or something like that. It's very labor intensive. So in the future we need that to be automated. Tell me when the truck leaves the area, or advise when the motorcycle pulls out of the hut. So that's an example of artificial intelligence. The other one is already it's data overload with these systems, and it's going to become probably orders of magnitude, I'm guessing, of data overload in SAT. So how to get an aggregated site picture from all of these vehicles that are talking to each other and flying with each other and performing specific parts of the mission. So those are just a few examples, I think, of some of the technologies that are going to be needed in the future fight.
Yeah, I think, from my perspective, I see, as we work with a variety of different vendors and companies and program offices, I continue to see a growing push to operate in a network of systems, and whether that data is coming in to feed your AI algorithms and give you a broader picture so that your AI can make smarter decisions, but being much more connected across a wide domain of technology. From global ELIN or SIGINT systems to space systems. There's just a wide variety of systems that a UAS now is really part of and working with every single mission. And so having good software-defined networking, having good various levels of command and control, so level 4 command and control to operate the system. Or have others outside of the aircraft command and control ecosystem operate the aircraft. A lot of these sort of technologies that start with, software-defined networking, hyper-converged computing, good apertures to connect to all of these different network systems. These are really important to get right so that you can participate in this more complex battle space with all sorts of other systems in it.
I would probably add to that GPS contested environments and being able to operate in those environments.
Okay.
You know, I'll add one if you guys don't mind. And this is not in my area of expertise, but it is a focus area, and I'll call it attritable technologies. So affordability has always been important. It's becoming more and more important. I noticed, I think it was on the actual, I think it might actually be on the Skyborg program. But in any case, you know, the DoD leadership is saying that these things are not expendable, but loss is expected, and you expect attrition. And so how to make them affordable to be able to take losses is another, I think, that's probably in the, I guess that's probably in the design and the manufacturing area. But that's
Yeah, I was gonna bring up with all of the AI stuff that we were talking about and the communications, and it is the robustness of these systems and what is expected, because it's one of those things, you know, cost, speed, and all that. You can only take 2 or 3 of them, right? You know, so what's going to give, and that's going to be an interesting way that we approach this. Is it, you know, cost per unit? Is it something like you said, the attritable nature of it is going to be interesting to see how that plays out.
Yeah, and that's a topic that we have as well here with ours is cost and repeatability. On the manufacturing side for us here at Kratos, it's you want to be able to build a repeatable product again and again and again, but obviously cost is a big factor because they are expendable. Especially in my line within Kratos, the Firejet line is an expendable aerial target ultimately. So it's made to not come home after X many flights, and so yeah, that's a very, very good subject to go into. Where do you guys feel basically as multi-domain warfare becomes more asymmetric as the advantage? What do you guys feel are the key technologies that the UAS community should be considering driving forward? I mean, obviously cost is a big one we just talked about, but what other areas do you guys feel would be an advantage of the UAS?
Yeah, I think you know, certainly hyperconverged computing, so really tightly integrated networking and processing, small onboard AI processing that's low power, but also onboard cross-domain solutions, multi-use apertures that can be used for communications as well as electronic warfare. A lot of these subsystems need to be reevaluated in how they're used for a variety of functions beyond just kind of one core function.
Yeah, I think the comms piece is going to be huge with all that. So you can do all that on board. You still have to get that information back to somebody, and so the ranges now become important as well. How well you can project that or get that communication. Whether again are you GPS limited or not, and how are you doing that? A SATCOM or not? Same thing.
Cliff, you have anything you want to add, or you want
to? No, really. That's I don't want to repeat it, so no, I'm good. Thanks.
But I would just say, other than the obvious communication, the AI and all that, you know, some of the things that we've been traditionally working on in the last 10 years still need to be improved on, and that would be maybe signature control, right? The signatures that these things give off, whether it's RF, acoustic, or IR, those things, the technologies to improve those are going to be something that's still going to be needed, as well as increasing endurance, range, and payload capacity.
And I'll just add on and kind of echo I mentioned cross-domain solution, but it's the broader information security and control framework across the platform. You know, in one mission, you might be supporting a very traditional overhead surveillance mission where you might be providing comms relay and just situational awareness to troops on the ground, and you're passing them data that's, secure but unclassified. And in other mediums in the multi-domain world, you might be interfacing with very classified networks or systems, and having the right architecture on board the aircraft to share and move this data. And sometimes much of that data is relevant across multiple security enclaves. How you manage and move that data across the system, I think, is very important in multi-domain warfare.
I guess that can cross. That certainly can cross services. It can potentially cross allies that we have, and so yeah, I agree that that's going to be important. The other thing I'm just thinking about here is traditionally our products have not been able to. They haven't been certified to operate in commercial airspace, and so one of our new product that we're working on currently, that'll be in service in a couple of years, is going to be a certifiable aircraft to operate in commercial airspace. That's a new technology that particularly internationally is going to be important in the future.
Well, that kind of leads us into the next one, which, after that we'll start taking questions, but where do you guys see, as being to enable more of the future? Is it coming from industry leaders, academia side of it, contributing to drive that, or government regulation or deregulation to allow broader standards? A lot of the areas we're going into are unknown. It's definitely the future, and we're developing this every day as we go along. So where do you guys see kind of what's going to be the biggest push to enable our future going into this unmanned sector?
Well, I'll just say, one of the things that is interesting to me is, like, first of all, the end user is always on the DoD side is always going to drive things. They're always going to ask for things that the engineers are going to say that's impossible or that's very, very difficult. And I'd like to get the perspective of the other panelists on this, how they feel about the tendency, and you can see this in so many different systems, right, to have the Swiss Army knife as opposed to having more dedicated systems that can solve a problem, and maybe it's a cost thing, right? But a lot of times when you look at those Swiss Army knife solutions, either they eventually work, but if you look at their track record in terms of cost, it's ridiculous, or you end up sacrificing so much of the technology. Do you kind of see us, a way that we may have more mission-oriented type UAS that are like in a family of vehicles that can do different things, or do you think they're going to always, hey, this one guy's got to do everything?
I would say that I think, all three communities have futurists. They have folks who are executing, programs and pushing things forward. And then you have a certain element of all of those communities that are compliance and liability protection and all of those aspects. I think ultimately it's going to come down at a national level to risk reward, and where are we willing to move, the levels of autonomy versus risk, and where are we going to move, certification of aircraft requirements and these sort of things. Right now you don't see a massive pressure that's fully built up yet, I think, to change the way we do things more broadly. I think every group wants the same things, but how we get there is still, I think, a value proposition more than anything.
So Jeremiah, so my answer I think you said where, who we work with. I think it's all of the above. So for example, I mentioned the FAA. We could talk about the European regulating agencies that we are working with and continue to need to work with. I know we have academia here, and so that's an important source of technologies. Somebody mentioned Wichita State, and I know they're here in NIAR. So we've worked with them doing human factors type of work, as well as fatigue testing for many, many years. We work closely with Kansas State. More recently, actually, that's a newer partnership just as of a couple of years ago. And actually, interestingly enough, there's a session going on right now that includes University of Oklahoma, I think, on global weather patterns. And so we've worked with University of Oklahoma to put together weather detection algorithms that are making their way now into our, we call it the due regard radar, anti-collision type of radar, as well as our links radar. So yes, on the regulating agencies, yes, to academia. And then I guess we already pretty much covered the commercial type of technologies that are out there and being developed. So anyway, it's very much of a partnership with us as an OEM, a private OEM, working with all those other companies and government agencies and universities and the like.
Okay. We've got probably 5 minutes before we'll open it up for questioning. Do you guys have anything you just want to, I guess, for lack of a better term, spitball?
I guess I could dovetail on the academic thing that Cliff mentioned. One of the things I think to look for as a business trying to leverage academia is to look for those universities that have a pretty vigorous hands-on engineering program. And by that, I mean, we do a lot of, and then and what the nice thing about UAS is that because of some of the scales that we're talking about, unlike when I was in the ancient years, when I was an aerospace engineer and we were doing paper designs on the next 737. Now they can actually design something that you can build and you can fly and you can actually see the consequences of your design. And that process, having the ability for universities to be able to do that helps a lot when you're talking about transitioning technologies, because it's that systems thing, right? The design that's on the paper that looks like a Swiss watch quickly turns into something very simple when you say, oh, well, how am I going to make that? Or, who's going to make it? Or, they have to make it themselves. So I think one of the things to look for when you're trying to find that university academia help is to find those universities that have a very robust and vigorous, hands-on engineering program.
Hey, I'll add quickly here. You asked for spitballs, I think, Jeremiah. Hadn't heard it called that, but so here's one: speed and agility. Speed and agility. Back when I was working, I was talking with Rick before this started, and I worked fighter jet engines for a long time, and the programs I worked on took 15 to 20 years, okay, to go from early design into fielding. And if you take a look at the customer, and I'm thinking of Dr. Roper right now, just happens to come to mind, but if you take a look at where our customers are going, they're looking at fielding new capability in single-digit number of years affordably. Okay, so and then also, anybody that pays any attention knows that you need to be ready to move with the you need to be agile. And so even as we see, I mentioned Skyborg earlier, which a couple of us are involved in here. That's a program, and it's it'll change, over time, and it'll morph and et cetera. So, I mean, I guess it's always been true, but I feel like speed and agility are important.
I think if any of you guys have worked with the special ops community, we have, and I think you all have as well, you're very familiar with that, taking the normal developmental time and just cutting it in half, right? And the term fail faster is a mantra, where you're gonna run into dead ends and fail in research, but just do it faster, learn from it, and turn and pivot as fast as you can. So that's almost like you learn a lot when you're working with that customer relative to some of the other more larger DoD components.
Yeah, I would add on that the one challenge of this space is that speed and agility are often counter to certification. You know, getting a CS-23 certified aircraft doesn't mean it's necessarily safe. Just because you move fast and agile doesn't mean you can build a safe aircraft, but getting it certified is not necessarily the speediest or most agile thing to set out to do.
And I would bounce on that as well, because we're in the same market. I'm sure a lot of you guys have seen our Valkyrie line, and that was 2 years from start to in the air, and it's still in development to this day. I mean, there's yes, we've flown them, yes, we've done very well, but they're still developing every day as well and changing. So it's the fail faster is definitely the mantra. I mean, it's you want to get over those hurdles as fast as you can, and when they knock you down, get back up and clear the next one in front of you, because they are definitely there.
The other thing is the risk assessment that they have to have in terms of like accepting at first maybe an 80% solution, right? Which is an anathema to a lot of engineers, right? You always want to constantly get it perfect, but sometimes in certain customers, you know, 80% gets you going, and then you do spiral development. But you know, that's another kind of way to attack the problem.
Yeah, I fully agree. We've got, looks like 13 minutes left on the clock, so let's see if we have any questions out there. I know there's nothing typed in at the moment on the chat, but I think most of the panelists should have a deal where you can raise your hand, and we can go from there. If I can figure out how to do it. I don't see any questions popping up, but I don't know, maybe I'm doing something wrong as well. So maybe you guys just covered the information so well that we're
Right.
There's a question.
I think there's one.
Yeah, I see one that just popped up. I'm not sure who it's from, but as a small business, how can we prepare to become a defense contractor? What's the best, what's your, and we'll just throw that out to the group.
I'll field this as a serial entrepreneur and someone who started two defense companies in the UAV space. You know, you can be a great technologist, and there's a lot of good ideas out there, but really starting with a good problem to solve, I think, is the first and foremost thing from a business model perspective in this space. This is a really difficult market with not a lot of customers relative to, you know, many other commercial companies. And so from that perspective, I think spending a lot of time getting the right problem to solve and focusing on that, I think, is probably the most important thing you can do. From the nuts and bolts of becoming a defense contractor, I think there's a lot of great resources out there. You know, a lot of great communities like NDIA, AFCEA, AUVSI, et cetera, that you can be a part of as an individual and launch a company and get connected into this market space. There's a lot of resources through Small Business Association and others to start a company and to launch a company and become a defense contractor in this space.
I would just quickly add maybe another big thing would be the facility clearance that you would need, and going through that whole process. It's not a quick process to get clearance levels of your facility for different levels that you might need to have to play in this space. That's another something to think about.
And not to oh, go ahead, sorry.
That's okay, JD. Go finish up, then I have a comment.
I was just going to say, not to dissuade anyone from going to this space, but I do think, you know, the DoD has made a concerted effort to start working with new kinds of companies and to work with startups and bringing them into the Department of Defense and trying to leverage new ideas and concepts. But I do think there is a level of inside game here, if you will, within the defense industry that's still yet to be fully broken down. I think there is a lot of opportunity in this space, but I do think, you know, having some time in your career working with this community before you take the risk as an entrepreneur is something I would certainly recommend.
Just quickly here, and at the risk of stating the obvious, so I've worked at basically larger companies, big companies for 3 decades. So performance is obviously important. And so, you know, you may want to start as a subcontractor to one of the big primes before you move into the prime area. But what I used to always counsel smaller businesses was hit it out of the park right off the bat, even if it's with a smaller, you know, type of contribution. Don't put yourself in a situation where you're not going to be successful. And so build that, you know, build that history of performance is what how I coached some of the companies I've worked with.
Okay. Good. We got another question from Reagan Mitchell. How important is collaboration between industry leaders in the vein of innovation for our UAS technology? Rick, jump on that one. I see you seem ready to go.
Well, just in the point that, you know, especially speaking with some bigger company like General Atomics, and how you do deal with other smaller companies or companies same size in terms of IP, universities and IP issues and things of that nature. It's very important, but it's also, you got to play that, you know, be very important about how you have those agreements placed, and sometimes they can be limiting. But I think it's important to work with other companies that bring the total sum of the parts that are better than the individual parts. But I think sometimes that can be a little bit you know, sensitive about dealing with company IP, where you firewall and where you don't. I don't know what your experience has been, Cliff and JD.
Well, so, I mean, yes, it's very important. Yes, very complicated. We're in a small space here, was already mentioned. And to some extent, we're competitors. In other areas, we cooperate and even partner. So very complicated, but also very important. And also the only other thing I'd mention is, and there are I think of AIAA, for example. You know, it's just one example of where industry comes together for common causes. And so I think that sort of collaboration at the industry level is also very, very important.
And I would agree with that as well. It's a very fine line with what you can and can't share with other industry leaders, and that's probably one of our biggest challenges is getting the insight without giving out the insight at the same time. So it's a very complicated and delicate, a lot of NDAs being signed, I can assure you. JD, do you have anything to add on that one?
You know, I think you guys hit on a lot of the core points. I just think that, you know, having good relationships across the senior leadership teams of most of these companies, I think a lot of it starts there. I've seen that on many programs where, you know, you would have the CEOs of major companies work very closely together, you know, just knowing that it was very important for them to navigate these kind of lines carefully.
Okay. We'll go one more question. We have 5 minutes. So what's the biggest barrier for your company's growth at this time? I'll jump in this real quick. For us right now, which I know everyone's heard this, is a lot of it with COVID. Vendors shutting down, being able to get product in the door to build our products. We use a lot of composites, and so there's a lot of shortages worldwide, which, I mean, obviously, you know, we do a lot of Department of Defense contracting. So we were cleared to work all the way through the shutdowns at all facilities and things through there, but a lot of our vendors were not, and that's really starting to affect us now as everyone's running out of inventory. What back backlogs they had of connectors and pins and everything there is starting to affect us now. But sales are good. It's just getting things in the door for us right now is our biggest challenge of growth. Where do you guys feel you're at?
I'll take it. Yeah, so it's certainly impact in 2020 and budget priorities. We had difficulty moving people around the world, just like everybody did. Our company's grown 19% year over year for the past 20 years, and we won't hit that this year. So this year is certainly a challenge. But if you kind of put COVID aside, and I think part of the title, part of the title of this session was shrinking defense budgets. I mean, that's always a challenge. And I liked I think JD, you said it, have a good problem to solve. So to kind of overcome that, and I talked a little bit about, swarming of disaggregated systems, and that's become a priority now. And so that's a good problem to solve. So be working on the next, the problem that we're going to have after the next problem, and to overcome some of the budget realities and some of the challenges, world challenges that we have right now. We've always kind of, the company, General Atomics, always felt like had a build it and they will come mentality, and that's worked for us. And I know a lot of people on this call and at this forum are entrepreneurial types that are the build it and they will come sort of folks. And so in any case, that's worked for us, and we expect that to continue to work.
Yeah, for Skydweller, I would second what Cliff said about any newer company in the space. It is all about execution initially, and for Skydweller, it's certainly, we're execution focused really for the next 2 years pretty heavily, and just making sure that we delight our customers and excel at everything that we've set out to go do.
I concur with what you said in general. I'd say we're at a different part in the curve. We're growing, and so I would just add, getting good workforce, getting good conduit of good engineers and researchers and others to help us propel that is making sure that we can maintain that conduit of skill sets to help us, I think, in addition to what you guys mentioned.
All right, we're about at time. We got another question, which is actually a really good one for all of us. But each of your companies have been attracted to Oklahoma and Kansas for various reasons. Can you comment on what brought your attention to this area of Oklahoma, or this area of the U.S.?
Mine's easy. I'm from here. I had attachment to OSU. I know what their UAS technology development, how their engineering program is, and that was a big, strong attractor for us. The fact that we can leverage that, and as well as Wichita being very close, being able to capitalize on some of the things. I think General Atomics is capitalizing on some of their facilities and capabilities. So it's a very fruitful area here in aerospace, and specifically UAS, including small company, aero companies like Zivco out in Guthrie that make the Edge 540. They're very competent composite manufacturer that's very nimble that we've drawn on. So
yeah, Skydweller just ran a kind of process to establish our U.S. And world headquarters here in the U.S. And we looked at a lot of states, and we ultimately selected Oklahoma. And really it was centered around a couple of core things. But one, I think the state truly as a commission, top to bottom, from the senators to the governors to much of the local business community to aerospace. And so between the talent that we could get through the great universities, the overall support for this industry in the state, and just the great quality of life that we can provide our employees there was the reason we chose Oklahoma.
Yeah, copy all that just briefly. I know we're running out of time. We are not headquartered in Oklahoma, but we actually do have a sister company, Systems Integration, that is here with us at the Tech Forum that you can come and talk to. And so whether it be University of Oklahoma, like I mentioned, and the capabilities they brought, or supporting our Air Force customer right in Oklahoma City. I haven't ever lived in Oklahoma. I'm a little bit jealous of those that do, and so maybe that's in my future, but I know it's a great place to live. I've certainly spent a lot of time there with our Air Force customer, prior life. So yes, yes, and yes, I think on all of those, Jeremiah.
Yeah, and I would concur with those as well. And we're headquartered out in California, and that's where our main bases are. It's where we've been manufacturing forever, at least, you know, since the existence of our company. And I mean, we just, you know, bought a 100,000 square foot facility here, stood it up from the ground up last year for this Firejet line. And all in all, I mean, yeah, Oklahoma's been a great place. I'm from Oklahoma as well, so I would like to think Kratos came here because I was here. Probably not, but yeah, great universities as well. So definitely, that's pretty much all the time we have today. I'd like to thank everybody for being on the call with us. If you guys have any questions, please go to these guys' websites, check them out. Feel free to contact any of us directly, and I appreciate everybody having time to sit with us today.
Thank you.
Thanks, everybody.
Thanks.
Bye-bye.
Excellent. Thanks, guys.